Okay, so moving further, we have in detailed discussion of how exactly the incident ray and the reflected ray travel, or in general the reflection happens in both concave mirror and convex mirror. Okay, now concave mirror is also called as convergent mirror. Convex mirror is also called as divergent mirror. Why concave mirror is convergent and convex mirror is divergent? In the explanation you will come to know. Now we have the convex mirror. You know what is the convex mirror, right? This is the convex mirror. We have the principal axis. Along the principal axis, what are the things present? One is center of curvature, and we have capital F. Capital F is called as principal focus. I repeat, capital F is called as principal focus. What is the importance of principal focus? Let me tell you. Now, the distance between, remember, the distance between principal focus and the pole of the mirror is called as focal length. That is small f. Don't confuse. Capital F is principal focus, small f is focal length. I repeat, focal length of a spherical mirror is defined as the distance between the principal focus and the pole of the mirror. Then you can also, what do you mean by radius of curvature, as I was explaining? So radius of curvature, one definition is, it is defined as the radius of the hollow sphere of glass of which the spherical mirror is a part of it. How to observe here radius of curvature? Radius of curvature is the distance between center of curvature and pole of the mirror. I repeat, radius of curvature is the distance between center of the hollow sphere and the pole of the mirror. Okay. Now, all these are at different positions. Okay. Now, what is this speciality of principal focus? Remember, whenever the incident ray coming from any source is incident on the reflecting surface of the concave mirror, means inside the reflecting surface of the concave mirror, compulsorily all those reflected rays has to meet or has to pass at principal focus. Okay, I repeat, whenever the incident rays coming from the source is incident on the reflecting surface of the concave mirror, all the reflected rays should meet at F, capital F. What is that F? Principal focus. Okay, you can see here there are many incident rays above and below the principal axis, and they are getting reflected at principal focus. Compulsorily it should go at from principal focus. Now you can ask me a certain doubt. Sir, you have got an incident ray and there is a reflected ray. Can we expect a normal, or can the law of reflection be obeyed to this mirror also? Why? Because the law of reflection we have studied only for, or the surface was plane mirror or a regular surface. Now here the mirror is spherical, right? Now you can see here, even though you have a spherical mirror, you have an incident ray. Okay, you have some incident ray here. How to draw the normal? It's very simple. Now see here, you can draw tangent to the circle, right? The line which is drawn at the circumference. When one point it will meet the circumference of the circle. That's the circumference, right? Now you can say, if I draw a tangent to this circle, obviously I get some point, and if you draw a perpendicular line to it, so you will get incident ray, and this is normal. So principle of reflection holds good here also, even though the mirror is spherical. Okay, law of reflection holds good. Okay. Now, so as I was explaining, now see here, this small f is called as principal focus and capital F is called as focal length. You can see these reflected rays are meeting at the principal focus. Now, why it is called as convergent mirror? Concave mirror is called as convergent mirror. Why? Because all the reflected rays are getting converged at principal focus. Converge agtide. Converge agodu andre eno ella rays seri one fine point or one point alli enagutte ella meet agutte. So that is known as getting converged, okay, or they all meet up at one common point, that is called as principal focus. Now moving to convex mirror. As opposite to this concave mirror, convex mirror is called as divergent mirror. Okay, now we have to be very careful while drawing this ray diagram for the convex mirror. See here, now this is a convex mirror. You have the reflecting surface to be away from the center of the sphere and non-reflecting surface is inside. You can see here in the diagram. Now as usual, the incident rays are coming. You can see the principal axis which is passing through the pole of the mirror and the center of curvature. You can see here the center line. Above and below the principal axis you are having the incident rays. Now when these incident rays are made to fall on the reflecting surface which is outside, now the sphere is the radius, center of curvature and the principal focus is within the sphere. You can see here. But the incident rays are coming outside the sphere. So where can you expect the sphere or the shape of the sphere? It is here, not here. So when you are expecting the symmetry or the shape of the sphere or the circle to be here, within which you have the principal focus and center of curvature, obviously the reflected rays should meet at principal focus as I explained. Because in whichever mirror it is, concave or convex, the reflected rays has to meet at principal focus. Now you can see here, reflecting surface is outside, non-reflecting surface is inside. Now you can see I have drawn the dotted lines coming from the principal focus which are meeting at the surface or the boundary of separation of reflecting and non-reflecting surface. You can see here. These are the various points from where I have drawn the dotted lines coming from principal focus. What is the importance of the dotted lines? They indicate that the reflected rays are getting appear to be coming from principal focus. They appear to be coming from principal focus in a way saying that apparently these incident rays when it falls on the reflecting surface, okay, even though there is non-reflecting surface on the other side, they appear to be converging at principal focus. Okay, they appear to be, it's not real, they appear to be. So coming from principal focus point of view, these rays are coming out of the principal focus and they are meeting at these points along the spherical mirror, that is the boundary. Now from there you just draw the same straight line, okay, outside. So those are the reflected rays. You can see here, these are the reflected rays. So here reflected rays are within, here it is outside itself. Now how do we say that these reflecting rays are assumed to be coming from or appear to be coming from the principal focus, which means to say that they are meeting at principal focus, apparently speaking. So you have to be very careful while drawing the ray diagram of the convex mirror. Since these reflected rays are coming from the principal focus and they are getting what? Diverged. They are getting diverged. Okay, they are moving in different directions. That's why it is called as divergent mirror. So convex mirror is called as divergent mirror. Now, wait. Now here we have the relationship between focal length and radius of curvature. Capital R represents radius of curvature. So what is the relationship between the focal length? I define what is focal length, the distance between principal focus and pole of the mirror. So focal length is given by R by 2. So how do we say that? Focal length is half the radius of curvature. Or if you cross multiply 2f, so what do you get? Radius of curvature is twice the focal length. I repeat, focal length is half the radius of curvature, or radius of curvature is twice the focal length. This is the relationship. Thank you.